My name is Mariah Diaz, and today I am going to discuss the Iterator design pattern. My name is Mariah Diaz, and today I am going to discuss the Iterator design pattern. The Iterator pattern is a behavioral pattern, specifically an object behavioral pattern. And behavioral patterns describe patterns of communication between objects. And object behavioral patterns specifically use object composition rather than inheritance to accomplish their goals, which is what the iterator pattern will do. So what is the iterator pattern? By formal definition, it is a design pattern in which an iterator is used to traverse a container and access the elements within said container. The formal definition actually can be used to describe the intent of the pattern, which is to traverse a collection without exposing the underlying representation or the structure that is being used for the container, whether it be a list, a stack, a tree, a vector, an array. The goal and the intent with the pattern is to hide the structure from the client and the user. Really what's behind wanting to use the iterator pattern is the fact that adding traversal algorithms to your structures are kind of counterintuitive because you're using a container object to kind of be efficient with your data storage. But the more that you add these traversal algorithms, the less efficient your data storage actually becomes. And in doing so, you may accidentally induce coupling, which you tend to want to avoid in order to make your software more reusable. And another motivation behind it is to extract the traversal behavior of the collection into the iterator, hence why it's called the iterator pattern and why you're using an iterator to traverse the collection in the first place. So how would we apply this pattern? We would apply it when we're using complex data structures, but we're not too sure what the complexity is going to be of that structure. We will want to reduce the duplication of traversal code. You don't why make 500 different traversal codes when you can just use one pattern and use it on that software. It's handy when you don't know what kind of data structure you're going to be using, whether it be a list or a stack or a tree. We don't know, but an iterator can help kind of alleviate some of those worries. You may even find yourself working with a software that multiple data structures will need to be traversed, and instead of writing multiple different ways to traverse each structure, using an iterator will again alleviate that pain. Even multiple traversals of the same objects can be performed with the iterator pattern as well. So here we have the basic structure of what the iterator pattern would look like in general. And first, the iterator interface will declare the operations required for traversing a collection, fetching the next element, retrieving the current position, restarting iteration, etc. Then the concrete iterator will implement the specific algorithms for traversing the collection, and the iterator object will track the traversal progress on its own. Third, the collection interface declares one or multiple methods for getting iterators compatible with the collection. And the concrete collections return new instances of a specific concrete iterator class each time the client requests one. And finally, the client works with both collections and iterators through their interfaces, and this allows for the client to not be coupled to any concrete classes, and this enables you to use various containers, various collections, and iterators all with the same client code. With every software pattern, there are participants, and the participants of the iterator pattern are, of course, the iterator, which defines the interface, the concrete iterator, which implements the iterator interface and keeps track of the current position for the iterator, the aggregate, which defines the interface that creates the iterator, and the concrete aggregate, which will implement the iterator creation interface, and it also returns a concrete iterator. Like any design pattern discussed in this class, there are consequences to using the iterator pattern. One of them is that it supports variations in traversal of the aggregate. Complex aggregates have many ways that they can be traversed. So iterators make it easy to change between these traversal algorithms. So you can just replace the iterator instance with a different one, and you can define subclass iterators to support new traversals as well. Another consequence is that iterators simplify the aggregate interface. Basically, the iterator's traversal interface obviates the need for a similar interface in the aggregate, which simplifies the aggregate's interface. And finally, there's more than one traversal that can be pending on the same aggregate, and an iterator keeps track of its own traversal state. So you can have more than one traversal in progress at once. The iterator data pattern is a pretty common design pattern, and it can really be used any moment where you don't want the container data structure to be revealed to the client, or really you don't know which data structure you're actually going to be using, and you really just want to play it safe to cover all bases. So now I'm going to kind of walk you through a very basic pattern example that just kind of shows how this works at a very basic level to get an understanding of the pattern. Here we're going to take a look at the class diagram for the example, and I really just want to focus on the fact that the concrete iterator inherits from iterator, and concrete aggregate inherits from aggregate, and they utilize the interfaces to add and traverse and almost manipulate the container structure that is in the example to add to it and inform the user that things have been added to their list. Just a quick look at the beginning source code for the pattern, just creating the basic skeleton for the iterator class, the concrete iterator, which as you can see does inherit the public attributes of the iterator class. Same with the concrete aggregate class, which inherits the public attributes of the aggregate, which creates a pointer to create an instance of the iterator class. Within the concrete aggregate class, you are creating a string of vector of elements that will be added to the user's list, and in a pointer instance of the iterator, which will traverse through the vector created within the class as well. There's functions to read the size of the vector, add to the vector, and get the current index of the vector. It's all housed within the concrete aggregate class. A final look at the source code for the example. You have a Boolean that determines whether or not you are at the end of your list or vector, and then you have the current item, which just returns where you are in the index, what object is being housed or value is being housed at that specific index within the structure. The client code I created one that just talks about games being added to my list that I enjoy or movie posters in my collection, and it will add it to the list. And as we'll see in the output, this addition using the iterator and the concrete aggregate structures is successful. So as stated, the code was successful. The games Persona 5 Royal, Final Fantasy 15, Assassin's Creed 2, Dead by Daylight, and Majora's Mask were all added to the game shelf. Meanwhile, the movie posters received Game of Death, Battle of the Five Armies, and Gone with the Wind in the collection as well, which the user can see in the console output. Again, that was a very basic overview of the iterator pattern. Just to restate, it is used to keep the container data structure within a software kind of hidden from the client code. It's also very useful if you don't know going into the development what data structure you're actually going to be encountering and using. So it makes life a little bit easier when you can manipulate any data structure using just one pattern. This is just a slide of the references I used, the textbook, Refactoring Guru, and another gentleman's blog, which he kind of goes in depth about the iterator pattern and other patterns as well. Thank you for watching and have a great night.